Hello, everyone. Thank you very much for joining our roundtable session today that's titled From Wired to Wireless Factory Automation. My name is Gabby Danieli, and I'm the Chief Strategy and Marketing Officer at Cortigo. Cortigo is focused on developing wireless solutions for factory automation that are based on the IO-Link wireless standard. I'll be moderating today's session, and the focus of this roundtable will be to discuss the general trends and the requirements that are leading the industry to deploy more wireless solutions at the OT level. From an industry that has almost strictly been relying on wired and cabled solutions and deployments, to an industry that now understands that high-performance wireless communication for factory automation can actually further drive a broad range of benefits and applications that were not feasible before. So now, I'm delighted to introduce to you our distinguished panel of industry experts that will be sharing their thoughts with us today. I'll start off with Mr. Ralph Franca, who is a Cortigo board director. Ralph, please. Ralph, you're on mute. If you can unmute yourselves, please. Okay.
Okay, yeah, thanks for the hint, Gabi.
No problem.
Yeah, thanks for handing it over to me. So I think it's very obviously that in the modern greenfield factory, which is planned today, the way of producing products is totally different than it was in the past. It's not a fixed asset where every process is clear how the product is being produced. It is much more flexible because mass customization and more different products to be produced in the same environment is a demand for a modern factory of the future. So that means factories, the machines, they have to be flexible, they have to be connected in different sequences, dependent on the product is maneuvering himself or itself through the shop floor. So that means wireless communication gets a bigger demand in the future in both aspects. As 5G is entering the factory itself, it's also necessary to have this flexible operating of machines and communication of machines and the product. And that is very obviously that's only possible with a wireless solution. So then talking about brownfield applications, it is also a huge installed base there where the demand is to make it more and more flexible and more reliable and efficient from day to day. That means you need additional sensors, you need additional actuators, HMI, and this installation has not to be done only by the specialist of the OT engineering department of the company. It has to be done by the shop floor manager himself or herself. And that means it has to be easy to be operable and easy to install. Again, another demand, a very high demand for wireless solutions, because you can imagine to install a wired sensor in a fixed machine is a much higher hurdle to make it happen. So this is, from my point of view, a summary of my experience in factory automation, both process-oriented and the hybrid ones and the discrete ones for the higher demand of wireless communication in the future, Gabi.
Yeah, thanks, Ralph, for the overview. By the way, Ralph also has recently been working for Siemens since 1985. You know, he brings decades of leadership and expertise in the industrial space, and some of his past roles included the CEO of Siemens Industrial Automation Systems Business Unit and the CEO of the Siemens Factory Automation Business Unit. So thanks, Ralph, for this initial overview. With that, I'll introduce our next panelist, Mr. Ashwani Singha from Schneider Electric. Ashwani, please.
Thank you, Gabi. Good afternoon, you all. You hear me right? Good.
Yeah.
Okay, thank you very much for inviting me to this roundtable. At Schneider Electric, we are driving actually the digital transformation by integrating processes, technologies, and products to eventually manage integrated management of data centers, infrastructure, and industries. Myself, since last 15 years, I've been involved in development of various wireless products for different applications. And presently, I'm leading a team of engineers in Schneider Electric France. The guys are building different Industry 4.0 products. So I'm very happy to be part of this panel today. Regarding the wireless and the industrial automation, in addition to what Raf mentioned earlier on, a key element in factory automation, often forgotten though, is the operator itself. The operator, rather I should say augmented operator, because it can see, touch, smell, hear, and as well as react when there is an anomaly. And for this operator, wireless communication is required to ensure mobility, at the same time to ensure that the data that he is generating, control data and both that monitoring data, it is also integrated in the end-to-end automation flow. So this aspect would be critical also from my point of view for industrial automation.
Yes, indeed. Very interesting. Thank you. So next up from the Zimmer Group, Mr. Marcel Pfeiffer, Head of Design and Brand. Marcel, please.
Hello, my name is Marcel Pfeiffer. Good afternoon to you all. I'm responsible at the Zimmer Group for the areas of industrial design, brand, and this goes also to marketing and a little bit in the pre-development. My history behind that is I started my career at Airbus, development and design of the A380. After that, I was in the non-civil development of the Boeing Corporation in Palmdale, a little bit in the sports industry, and after that, I worked for HOMAG, developing woodworking machines. Well, and now in the Zimmer Group. The Zimmer Group is a company developing components, systems, and machines. We have about 1,300 employees and about 180 million turnover. And our goal at the moment is to develop high-value components with a high standard of precision and making that really easy to install in nowadays Industry 4.0 environment. And I think at the moment we're on a good way. We're offering HMIs to our components, and we have our own control platform. So, well, that's all from me for now. Thank you all that I can be part of this roundtable.
Thank you, Marcel. Next up, we have from Protion, Mr. Rainer Buschholter, CEO of Protion.
Yeah, thank you very much. As you said, CEO of Protion and owner of the company. It's a German company located between Stuttgart and Ulm. We have basically three business fields. The first one we started with actually is the research and development for products and processes. So we do a lot of development and research for big companies, international companies, and we also build the prototypes to approve the development. Second business field is paper converting and packaging. These are machines that processes paper or cardboard or foils. And in these machines, we have very individual configurations of different processes, like printing, embossing, varnishing, whatever you can imagine. And the third field is automation, where we also make machines, especially for customer purposes, starting from an easy jig all the way through to fully automated, high productive, high mass production lines. And the paper converting as well as the automation business field is the field where we got the first time in contact with Iiot wireless. As you see on the very lower right picture, it's a new product designed by us. We call it the Orbiter. It's a new robot type. And Iiot wireless is one of the two core technologies for this solution. So I'm very glad to be a part of this round because we did enjoy the benefits of IO-Link. Thank you.
Thank you very much, Rainer. And our last panelist from Klostermans, Mr. Manu Pilman. Manu, please.
Good afternoon, everybody. My name is Manu Pilman. I'm product owner at the company of Klostermans, representing Klostermans. Klostermans is a family-owned business, sixth generation by now. We have about 230 team members at our company. The core business of Klostermans is mainly custom-made solutions for packaging, product handling, going from low speed to high speed applications. One of the strengths of the companies is that we have a complete end-to-end process in-house. Means that we're doing actually all our mechanical, electrical engineering, automation, manufacturing, assembly, and then the whole integration and the whole testing in-house. So we're actually independent from other vendors. What is our strength? What is our goal? That's the fact that we have customers from all over the world that are coming to Klostermans for turnkey projects. What's the strength there is that we're based on a complete co-creation platform. Means that we, with the customer, we look together into the solution that the customer needs. But on the other hand, as an OEM, as well with suppliers, we co-create and we leverage the existing technology to a higher level if needed, let's say. Happy to be part of this roundtable today, since that leverages or the leverage with suppliers, the co-creation with suppliers that you can do over there. Cortigo is a great example of what you can establish within a year, for example, with the basic, and then leverage it to a much higher level. So happy to be part of this roundtable and give background and information on a wonderful journey that we had last year together with Cortigo and what Iiot brought us so far.
Great. Thank you very much. Thank you, everyone. And let's get started here. So, we started a bit discussing some of the key drivers for wireless communication. We heard from Ralph and from Ashwani mainly about the fact that you need flexibility to produce many products in different processes. How do you get to mass customization? We heard from Ashwani about the better user or operator experience and the augmented operator. And I'm wondering, Manu, Rainer, Marcel, any additional thoughts on some of the key drivers for wireless communication?
I can kick off if needed. What we saw as a key driver for our platform, for our machineries, one of the things is that existing machines, you can easily upgrade with wireless components in terms of data collection and getting inside information. If you, for example, want to upgrade reliability, you want to know inside pressures, torque, and all that stuff. We're even implementing cameras on board of moving objects, let's say, when we're doing problem solving or stop code analysis as we speak. So yeah, let's say that was for us a big advantage, and we leverage that advantage a lot now these days to get more inside data in our machines.
Yeah. Okay, great. Upgrading insights. Rainer?
Sorry, yeah. The main driver, maybe I can share my screen and show the product we made.
Yeah, give it a try. Let's see.
Now you should see, right?
Yep.
This is the orbiter I mentioned before. It's a system where shuttles move around on a track in a certain way, let's say on rails. Each shuttle can do something, can handle parts or can machine parts. And this makes processes much more flexible and much more faster than it's possible with the state-of-the-art roboting. the key point for this system is that you get energy and communication on the shuttles. And as you possibly can imagine, with the system moving around, it's almost impossible to get energy or communication on the shuttles by wires. It's simply impossible, especially if you consider high dynamic processes. So the IO-Link wireless enables a technology that wasn't possible before. So IO-Link in this case is one of two technologies that are drivers for new opportunities in manufacturing machines. Okay.
Yeah, this is a great example for something that was not feasible beforehand. All right. Okay, great. Marcel, any other comments from your side on the key drivers?
Absolutely. The Simmer Group is aiming towards, mainly aiming at that point towards the reduction of complexity. We see that the wireless solution enable data connections also, like earlier mentioned, with systems that are not tied to a specific location. There you can see maybe shuttles, maybe also robots moving around, something like that, or HEVs. Thereby, wireless solutions are expanding the range of these applications and increasing their flexibility. And for all that reason, I think the drivers of wireless technology in the industrial environment are absolutely existing, and that's the reason why the Simmer Group strongly believed in wireless IO-Link, and that's the reason why we started in, let me see, 2017 with the first prototypes shown on business shows.
Nice. Got it, right? So complexity reduction, robotics, collaborative robots, AGVs, and so on. Great. So now I think, guys, we're seeing that there's some strong drivers for wireless communication, but it does seem that up till now, wireless has not really been broadly deployed in factories for automation. Why do you think wireless has not been used up till now so much? Ashwani, perhaps thoughts?
Yeah, sure, Gabi. One of the concerns often that we have heard from a customer is regarding the reliability of the wireless communication. Questions like whether it will work correctly in the presence of other machines interference nearby, whether the performance will be impacted by presence of another wireless network on the factory floor. So such questions have been asked often by our customer. To give you a concrete example, like in the past, we built a Bluetooth low energy based product for industrial control. And one customer in UK was, they were using the product since 2-3 years, all well, no issues. And one fine day, suddenly the product starts having trouble, like, frequent connection losses. And we investigated and quickly we found out the culprit. It was like a nearby location, a 4G relay antenna was deployed recently. So this coexistence with other technologies, we need to take into account, and such episodes do create some doubts in the mind of customers.
Got it. Thank you. Manu, any thoughts on this, on some of the, what caused manufacturers to feel less comfortable here with wireless up till now?
Yeah, like the last 2 to 3 years, as Rainer has showed as well, like the use of linear track systems is booming a lot. We all realize that let's say a track system can be used for a lot of good transportation stuff, but it's still quite expensive. If you can leverage that linear track system technology to a level which is 10 times higher and having components introduced on that linear track system, no matter which brand it is, it gives you an enormous, gigantic way of opportunities to do stuff. For us, the big issue there was the high performance that was needed from wireless components. If you have a track system working together with another system, that track system needs to be better than a wire. It needs to be spot on, it needs to be fast, it needs to be deterministic, It needs to include about everything to let's say, be able to interchange a wire with a wireless component. So that was for us, let's say, the big hurdle to have wireless components. We tested 4G and other stuff, Bluetooth and all the other wireless protocols that are on the market. But let's say they always just, in the end, in terms of performance and reliability, they just gave up on us until we went to the path of the Iolink wireless today.
Yeah, no, that's great. And I think it's also right what you're describing in terms of the solution. It's also the difference between monitoring and control, right? We're not just taking sensor data and using it for monitoring. We're actually using it for real-time control, where you had to get something that people can be confident with. Ralph, any global thoughts, Ralph, on sort of like why there was not, why factories were not feeling comfortable up till now?
Yeah, maybe it has to do with some stickiness in thoughts of a typical engineer thinking about how to make a machine running. But another thing comes in my mind, talking or thinking about wireless, a very, very big vertical is food and beverage. And you know, all the machines in food and beverage has to follow some kind of hygienic standards. They have to be cleaned very easily and very, very, very good with steam and things like that. And the biggest hurdle and the biggest headache for an engineer making a machine in food and beverage happen is the wiring. So you have hundreds of wires from the sensors of the machines going to a central or even a decentral automation unit. And this has to be connected to the machine without a channel. Each and every wire has to be handled solely and has to be sticked to the machine in a way that the machine can be cleaned afterwards. How many of those headaches will go away if you just change your mindset and trust to the wireless solution as a wired solution without wires?
Yeah.
So, and I think this is a very, very big opportunity in a really, really huge market, and totally independent of high sophisticated new technologies. It's just to replace thousands of wires which are not necessary any longer in the future.
Yeah. So I mean, sometimes it's just, you know, getting rid of old habits, right?
Yeah.
Yeah. Okay. Marcel and Rainer, any additional thoughts on this?
Yeah, from our side, we have the experience. There were general reservations, especially in Europe, in terms of the reliability, as mentioned, of these connections, and also some concerns about the data security a few years ago.
Yeah.
But nowadays, we see that this changes, and we could prove in some of our tests that these concerns are absolutely overcome, to be honest. And nowadays, we see, as mentioned, we tested it, that the wireless Iolink is as reliable and, let's say, like a standard cabled Iolink solution. And the Singha group has each and every component as a variation of Iolink, and in future maybe also the second variation in wireless Iolink. That's the plan behind that. I'm not really sure if we can really ramp it up that fast, but that's the vision behind.
Okay, that's great to hear. Thank you. Rainer, any additional stuff?
Yeah, essential for us is the standardization, because in a system we have a variety of different actors and sensors and so on, and it's essential to install a line or to make a line with a reasonable effort. If all these sensors and actors communicate in the same way, they can be set up in a very similar way or even in the same way.
Yeah. No, I think standardization indeed. And you know, it's important to mention here that IO-Link Wireless, of course, to the audience here, was designed exactly for this need. It's a universal standard. It's part of the IO-Link standard. It has a low latency of 5 milliseconds. The reliability is 6 orders of magnitude. It's 1 million times more reliable than Wi-Fi or Bluetooth or Zigbee and the likes. And also scalability. And I think we'll actually be hearing some examples in this session actually on how, you know, we've been able to reach with, you know, some of the vendors here, hundreds of wireless devices within a single machine area. And it's also designed to be deterministic protocol. So you're not really trading off between all of these things. You get the whole package. Now, I think at this point, our audience probably would be interested to hear, you know, what your customers are saying, right? What kind of customer feedback or requirements brought you to develop this line of wireless products? You know, specifically, what are the pain points you're addressing? Manu, perhaps you can start off talking about some of the pain points.
Yeah, for sure. Like if we're talking about, let's say, reusability of components and operator-friendly components in the machine, the first thing that it means that if I have a device or I need to interchange a device in case of, you know, what all can go wrong, let's say in a machine, it's not up to the operator to dive into difficult protocols to bring in new devices or wireless devices or set up IP ranges for a camera and all that stuff, since then you're actually not making an operator-friendly machine. You're bringing the experts back to the front, which is not what we want to. We want to design operator-friendly machines. So one of the key points is that it's so easy to commission new devices that you can have 30, 40 devices on track, for example, or I have 10 pressure measurements going on in the factory. You can easily shift and change without having a very deep dive knowledge based on automation, let's say, which makes it easy and possible to integrate, since our customer will not accept this kind of technology if it's very, very high end and if it's, let's say, difficult to use and to integrate and to operate, let's say. Right,
Got it. Great. Ashwani, thoughts?
Yeah, Gabi, for us, you know, on the industrial control side, we have been working on removing the pain of wiring and cabling devices in really difficult environment for our customers. And at the same time, ensuring that access to data is there for the Industry 4.0 applications for our customers. The target reduction on the TCO, the total cost of ownership for the new installation, is something also one of the, you know, the requirements often cited by our customers. On top of it, if I go to the let's say brownfield installation, so we talk about condition monitoring application for installed bases. The customer really needed to retrofit, have that flexibility of retrofitting his existing installation with a lot of secondary sensing sensors to ensure that these old installations, they are able to monitor and improve operational productivity.
Right. Good. Yeah. So total cost of ownership. Good. Great. Rainer?
Yeah, requirements by the customers that the systems or the production lines have to be suitable for short run. They're facing the situation of decreases lot numbers and numbers to produce in one lot. That means for the production line that has to be easy to change from one product to the other. Setup time almost to zero is something that customers are interested in. And with the wireless, we are much more able to change tools, to change the configuration of the machine. So wireless is certainly one important technology to give the answer for short run solutions.
Right. Okay. So higher capacity and much more flexibility and agility with changeover and setups. Good. Okay. And Marcel?
Our customer communicated to us that the solution are getting more and more flexible, that they are demanding this flexibility, but they're also demanding a smaller solution, a lighter solution, as you see as, for example, end of arm of lightweight robots. And they're of course looking to the reduction of TCO. So our customers are seeking both in the field of cobots and in the field of, let's say, conventional robots from middle size to even big size. They see the topic that our end of arm tooling in combination, let's say, with tool changes. In that field, a wireless IO-Link connection could mean a reduction in weight, in cost, and in complexity. Because on these tool changes, of course, you have, let's say, some energy elements that you add to the tool changer, but you don't need to add these if you use just a wireless connection. And from that point of view, the Singha Group is more and more gaining in the connection of wireless solutions. And at the moment, we're trying to save space on these solutions and try to save also here complexity and weight, because weight is the key element for installation of industrial robots, so that the customer can maybe choose a smaller size of a robot and save here a lot of money and also sometimes space and energy.
Yeah, that's very interesting. So we heard the easy commissioning, we heard footprint reduction, we heard weight reduction, increasing capacity, TCO reduction, of course, is very common all across, and getting to more agility and reducing changeover and setup times. All these are some of the things we're hearing from the customers. Great. So at this point, I think maybe we can discuss the actual solutions and applications. So what kind of wireless applications are you guys implementing currently? And what's the main benefit over wireless? Ashwani, perhaps we can discuss Schneider's short and long-term.
Yes, of course, Gabby. So what in the past we have already, started working some wireless, developing some wireless product. We can our products, we can split in two main categories. One is more from industrial control application products. So there it can be a simple push button, wireless push button for start, stop, select functions, and it can go more complex, like integrating emergency stops over wireless. And in the past, we have made some product with technologies like Bluetooth Low Energy, Zigbee, etc. And we have seen the limitations, and that's why now we are working on integrating the IO-Link wireless in these kind of products in the, let's say, near medium future, short medium term future. The other type of application that we also, though some products we build here is for the IIoT context monitoring for preventive and predictive maintenance of assets. So a lot of sensors, wireless sensors, data, aggregating this data and pushing for the analytics and new applications for our customer. Till now, these sensors were we were using more Zigbee technology, because we were not looking for determinism in the data or sensors, like there were no sensors in our portfolio for vibration, for example, which require a very reliable, faster, deterministic communication. It was more for monitoring temperature over days or a couple of hours. So Zigbee was sufficient, but now we want to push more, get more kinds of data to be monitored. And that's where we are looking for technology like IO-Link wireless again. Globally, both kind of application for us are, we strive to achieve reduced TCO for our customer, ensure the easy retrofitting, and for also the scalability of the deployed solution. That's also key, whatever product we are building.
Okay.
Yeah.
And Marcel, from a Zimmer Group standpoint, currently, is it focused only on the collaborative robots and the wireless grippers, or is it there's some other plans?
To be honest, we're at the moment we are planning and projecting, and at the moment testing in two fields. One is robots, not only collaborative robots, but also lightweight robots.
Yeah.
No heavy solutions at the moment in the testing, to be honest. And the other one is in our machinery. We're testing for our shuttles because we see a large benefit in that. And as far as the testing go, also at the customer, everything is really, really going very well.
Okay, great. Thank you. Manu, perhaps you can share with us some of the solutions you're deploying and that you're building.
Yep, happy to. If we look back, let's say, as I mentioned, to the two different types of wireless or ranges of wireless we can use. Like I said, one thing is reliability, like real on-time feedback in terms of milliseconds, which brings us a lot of insights in the machines and helps us resolving processes and fine-tune processes to a much higher level than we were able before. We don't need to look anymore to only high-speed video images, but we can as well rely on wireless data, which brings us a lot of insights if you put that on a platform, for example. The second one is wireless technology will bring us to the next level in the upcoming years. If we start thinking about the linear track systems and using wireless technology on linear track systems together with wireless power, it enables us to let's say, create a breaking point in the industry as well in terms of flexibility and reusability of tools. A customer doesn't need to, let's say, buy a new machine completely if he can just, for example, change the components being used on a mover system compared with in the past a whole machine that was, let's say, made for one SKU. So key is that repurposability of your whole solution can be leveraged like enormously, that the minimum amount of cost can bring you to a new type of machinery or a new type of application without changing the base. One of our biggest advantages was that I'm gonna refer to the fact of Ashwani as well, that you have pollution and disturbances in the field when you have a lot of stuff going on everywhere in plants. Today we were able to leverage the amount of devices, more than 300, let's say, which is enormously compared to what we are or where we were, let's say, last year when we kicked this one off. So the infinity of having numbers of solutions in one machine that is located in a plant next to all the other pollutions that you have in fields is one of the big key players in this topic.
Yeah, for sure. I mean, attempting to do, as you mentioned, 300 and something wireless devices with conventional wireless would probably not work. Yeah.
Wait.
Right. Rainer, you were sharing with us your orbiter solution. Any other things on top of that you'd like to share? How wireless will enable some of your applications?
Yeah, on all applications where we have to handle parts or handle objects in a very fast way. The wireless is, I think, essential because cables make the process slower because of their stiffness and, of course, because of their mass. So wireless communication enables much faster processes.
Mm-hmm. Yep. Okay, thank you. So I'd like to wrap it up with one last question for the panel, and let's get to a bit of a higher level here. It would be very interesting, I think, to know what relevance do you see for wireless communication to other Industry 4.0 aspects, in your opinions, beyond what was discussed. Ralph, can you perhaps provide us an overview and your thoughts on this?
I think we have seen a lot of nice applications where wireless brings your automation to the next level of performance and reliability, security, and safety. And I think this is something which will drive the industry further down the road in using wireless technologies. What we have to overcome is a little bit the skepticism of the industry against the wireless technology due to the fact that it has a history, but the technologies which are now introduced will be introduced in the market, like 5G and IO-Link wireless. They have a totally different aspect of reliability. What I like very much, and I think this will help IO-Link wireless specifically, is that we are sitting on a standard here which is established since years or decades, IO-Link wired. And that makes it very easy for the end customer or the machine builder to adapt what he has already done in the past using IO-Link technology, simple and easy and fast to wireless technology.
Indeed. Thank you. Anyone else? Anyone else thoughts? Ashwani, any thoughts on?
Yeah, Gabby, just another aspect that I was thinking that the one of the challenge for Industry 4.0 has been effectively enabling the convergence of OT and IT systems, and in that context, like adaptation of standards like IEC 61499 has been enabling like a transformation of legacy proprietary automation system towards a more plug and deploy distributed system, open platform. And combining wireless with this distributed control, I think it will provide the necessary hardware abstraction so new application can be created, because we can achieve this hardware abstraction combining especially reliable and robust technologies like IO-Link wireless with this new concept, distributed control. So this is another thing to look for, in future, I assume.
Yeah, beyond just IO.
Yeah, exactly.
Yeah. Okay. Manu, any thoughts on where this will go further as part of Industry 4.0?
Yeah, if we talk about Industry 4.0, let's say Clustemans is working for a couple of years on the adaptive process tuning, we call it. Means that we use data from the machine, but the machine needs to learn himself towards the best setting, which is, let's say, compared to standard AI these days, getting big data, pulling them through an algorithm and then introduce a new set of settings in the machine. We want to raise it to the next level and, let's say, use it as an adaptive machine that is using data which is picked at the moment on the fly, and then adapt the process to it. And then we notice, or the last year, we came to the point that then wireless IO-Link protocols are the key in that particular insight and gathering the data, since it gives you real-life information on what's going on in your machine. And then, the machine can start making his own mind and let's say work to the best setting. So you're creating a virtual operator that knows the best of all, let's say, without putting a lot of effort, energy, and knowledge on the table. So it's for us, it's the key to adaptive process tuning in the future.
That's great. That's fascinating. Great. Thank you. And Rainer, any thoughts?
Yeah, relevance of IO-Link for Industry 4.0. Industry 4.0 claims to be the fourth industrial revolution. And revolution means that you're doing things differently than it was done before.
Right.
And by that you generate a major benefit, not only for those who apply the technology, but also for a majority of all people, like it was for the first three industrial revolutions. So in terms of IO-Link, I think the IO-Link wireless technology enables new processes and new machines that can manufacture in a different way and much more flexibility than it was possible before. So with the with IO-Link wireless technology, you can do things differently than before, and by that you can generate a major benefit. So this is why I think the wireless technology is very essential for the Industry 4.0.
Yeah, no, I agree. It's a revolution. It's not just an evolution, right? Great. And Marcel, any final note on this?
Yes, the Singha Group sees the relevance for wireless IO-Link in the IoT, especially in data analytics, and of course for the topic of condition monitoring and predictive maintenance, as our end-of-arm devices are not only actors, but also sensors. We have implemented sensors, of course, in our products. And you can imagine the more complex a machine or a solution gets, the easier it is to collect all this data via a wireless signal or not via cables. And we're working on these configurations for quite a long time now. For this year, we could achieve the German Innovation Award for a wireless solution. And we're proud on that, of course.
Yeah.
And for the next, let's say, few years, we're trying now to push the limits, because we see that our products have reached a certain level, but it's not enough for us. We want to push a little bit further, and we see that also having a component in a machine, which is maybe a retrofitted machine in brownfield, not only we can tell about the condition of our component in this machine, we also try to get relevant data from, let's say, another component in the near of this in terms of, let's say, thermal abuse or something like that, or vibration. And at the moment, we're thinking about these aspects to be a real benefit for the IoT.
Right. So more condition monitoring, predictive maintenance,
Yes.
IoT. Yep, indeed. Okay, so guys, first of all, thank you very much. I'm getting signaled here by the organizers that we have a half-minute left, so we are right on time. We'll make sure to answer any Q&A and forward it to the relevant people if there's any questions later on. So again, big thank you for our industry experts, panelists here. This was, for me, a great session, and I hope that all our audience also got educated here and learned some new things about wireless factory automation. So thank you again, everyone. Take care. Bye-bye.
Bye-bye. Thank you.